So, welcome everybody. So today we will be seeing the solutions for JEE question paper PU2 dated 17/08/2023. This photo electric. Okay. Chirag Suspad, I think. Um, 11th question. So two cells of EMF E1 and E2 greater than E1 are connected in series and secondary circuit of potentiometer experiment for determination of EMF, right? The balancing length is found to be 825 centimeter. Now when the terminals of cell E1 are reversed, then the balancing length is found to be 225 centimeter. The ratio of E1 and E2 is, this is simple. So first time if you see the total voltage was E1 plus E2. That time balancing length was 825. 825 into 5, right? Then when 1 is reversed, that is E1 is reversed, then it is 225. You can write E2 plus E1. Then second time E2 plus of minus E1, that is E2 minus E1, because E1 is reversed. So this is 225. I will take a ratio here only if I cancel. Now if you see 25 9s are 25 3s are 75, and again 75 means 33. 3 3s are 3 11s are, right? And 3 you take that side, 3 2 plus 3 1 is equal to 11 E2 minus 11 E1. Then what you get? The 8 E2 14 E1. E1 by E2 they have asked. E1 by E2 is equal to 8 by 7, 8 by 14. That is 2 4s are 2 7. 4 by 7, that is 4:7, right? So option B. And we have 12th question. In a potentiometer experiment, the balancing length obtained with the cell is 240 centimeter. On shunting the cell with a resistance of 2 ohm, the balancing length becomes 120 centimeter. Internal. That is direct formula we have. That is at -1. So R is 2 ohm. Then L1 by L2, 240 by 120. And this is 2 minus 1 1. So your answer is 2. A voltmeter with resistance, okay, is used to measure voltage in the circuit. To increase its range to 3 times, the additional resistance to be put in series is. Now, what is the situation here? If you see, there is a voltmeter. So a voltmeter is there, right? And its resistance is 50 kilo ohm, right? Its resistance is 50 kilo ohm. Now it had some range, but now they are telling you have to increase range to 3 times. Range means suppose you applied some resistor like this and some circuit is there. So you want to find this voltage across this resistor. So you applied this and you got some value. So it had some range, suppose. Now its range has to be increased by 3 times. So now suppose it used to get full scale deflection when IV current goes. Right? Basically galvanometer coil with respect to current, it will show full scale deflection. So if IV current goes, Suppose it shows full scale deflection. So earlier it used to give full scale deflection at IVRV, right? That is resistance of the voltmeter. So this voltage will be IVRV. So for this it used to go for this voltage, IVRV voltage. This voltage and this voltage is same. So for IVRV voltage, it used to give full voltage, full scale deflection. Now when IV current goes, what should be the voltage here? Sorry, what should be the voltage here? 3 times earlier one, that is this. So now the voltage will be IV into RV plus, suppose you applied a resistor in series, RS. So now this is the voltage which it will read when IV current goes. So this voltage should be 3 times the voltage it used to read earlier. So now if you solve, what will you get? I have asked resistance value. So if you see IV and IV cancels, 3 RV is equal to RV plus RS is there. So 2 RV is equal to RS. So 2 times of this. 2 times of this. Into 2 if you do 100, 10 power 5. We go for next question for 14 point. Is the question. A galvanometer of resistance 50 ohm is converted into an ammeter by connecting a low resistance of value in parallel to galvanometer. Okay. The full scale deflection current of galvanometer is 10 milliampere. The maximum current that can be measured. Okay. So this is ammeter. Here galvanometer is there and here shunt resistance is there. This is converted to ammeter now. This is your ammeter, right? Now when okay, sir. So suppose maximum current that can be measured is I. So when I comes here, this gives full scale deflection, that is 10 milliampere. So when I goes here, 10 will go, 10 milliampere will go here. And resistance of galvanometer is 50 ohm. And the resistance of this is 1 ohm, right? Now, you see if I current, they are asking I now. They are asking what is I. So 10 milliampere current divides here, right, in parallel circuit. So current division formula I will apply. So current in galvanometer is nothing but 10 milliampere is nothing but I into, which is coming into, how much will go through galvanometer? 1 divided by 50 plus 1, which is 51. So I is equal to 510 milliampere. So it can measure 510. So when 510 comes here, 10 will go here and it will show full scale deflection. So when it shows full scale deflection, we can understand that how much is coming here, 510. So 510 you can measure. Forward value of R, the current in galvanometer is 0. Okay. We have to current in the galvanometer is 0. So if current in the galvanometer is 0, voltage across this will be 2 volt, right? Voltage across this is 2 volt now. If voltage across this is 2 volt, voltage across this is 7 volt. Because total is 12, right? Total is 12. And 12, 7 is here, and 2 is this side in this arm. Right. So voltage across this is 7. They're asking what is the value of R. Okay. If you see, this was also not required actually. If you see, there is no current in this branch, no. So I will just remove this branch. Now, V is equal to IR. If you apply, what you will get for this circuit? 12 is equal to I into, means whatever current goes here will go here also. V is equal to I into R. R is, they both are in series, 5 plus R. Because this I am cutting only this part. Because no current is going in this part. Then one more thing is, you know, voltage across R is 2. So 2 is equal to I into R. Right? We want R, I think. Yeah, we want I. So we want R. So 2 is equal to IR. Now, what we can do? 2 is equal to IR, so we apply that IR here. So it becomes 5I plus, or you can apply like this also. I is equal to 2 by R. You can put 2 by R here. So 2 by R into 5 plus R is equal to 12. 1 is 6R plus 5 plus R. 5R is equal to 5. R is equal to 1. So option D. Then go ahead. 16th problem. The circuit shown in the figure below, the cells E1 and E2 have EMF 4 volt and 8 volt, internal resistance 0.5. Okay, potential difference across. Okay. Now first we will find equivalent circuit. This 2, 6, 3, 2 parallel, 6 A parallel 2, 2, 2, 2.5 series, 4, 6, 6.5. These two are also in series, 1.5, 6.5 is 7 and 8. 8 resistor, 8 ohm resistance is there in the circuit, and voltage is EMF, if you see, this is plus minus, plus minus, this is stronger, so net will be this side only, but it will be 8 minus 4, that is 4 volt. So how much current is there in the circuit now? Current will be coming from here, this is stronger. Here also current will come, but this will dominate, and net current will be in this direction, right? So how much current that will be? 4 V is equal to 4 2 ohm I. Yeah, sorry, this is 8. I is equal to 1 by 2 ampere. Okay. Now if you here see, suppose this is the internal resistance, current is going like this, right? Current is going like this, so current will be like this throughout. Right? So current is going like this through this resistor, so this is plus, this is minus. Now voltage across this is minus plus, this is plus minus. Cell plus minus minus plus, so both will get subtracted. So V is equal to E minus IR. That is 8 minus I is how much I is, yeah, 1 by 2 into R is 1, so 7.5. So this is 7.5. So out of these two, one will be there. And here, if you see, suppose internal resistance is there, here or here, anywhere you can take. Current is going like this, so this is plus, this is minus, and this is plus minus, plus minus, plus minus. So both the voltages will add up. So E plus IR will get. That is because both are having same polarity, right? Plus minus, plus minus. So if you go from here to here, plus minus, minus, minus E, plus minus, sorry, minus IR, plus minus, minus, minus E. Minus IR, minus E is like adding both of them, right? So EMF is 4 plus I is half, R is half. So both are half. 1 by 4, 4.25, 4.25. Option B. Right. And go for 17th problem. What is 50 electric bulbs, all identical, are connected in series across the main supply. So 50 bulbs are there, and each bulb is like one resistor. Like that, 50 are there. Is connected to 220 volt. After one bulb is fused means it went off. It's removed like that only you think. The remaining 49 bulbs are again connected in series because the same. Now 49 are there, but this main supply is not 220 only. Main supply is 221. Elimination will be okay. More with 50 bulbs than with 48 bulbs. See, number of bulbs which will decrease, R will decrease, net R will decrease. Net R decreases, V is equal to IR, I will increase. Right? Because V is constant. If I increases, then P is equal to I square R. R is for each bulb, R is constant. but for each bulb I is increasing, the current which is going in each bulb is increasing, so power will increase actually. So if you apply less bulbs, you will get more power from each bulb, right? Means illumination power, each bulb is illumination, so it will be more with less bulbs. So this is correct, right? Equal in both cases is wrong. For B1 is correct, obviously, and fourth one is wrong. You can check for that. So P is equal to V square by R also for each bulb, I am telling. So for in first case you see, for each bulb V is 220 by 50 and full voltage 220, 50 bulbs are there, so each bulb will get 220 by 50 voltage. Voltage will divide equally as they are identical bulbs. So 50 so square whole square is there by R. So this is initially, this is P1. P2 will be 220, now 49 are there, so voltage will divide like this. Now if you see ratio P1 by P2 they have told, second, first and second case respectively. So P1 by P2 will be 49 square by 50 square. That is 49 square is to 50 square. But they have to 50 square is to 49 square, which is wrong. Yeah. One more thing is, in first case they are telling illumination is more. Second case illumination is less. Second is 49 bulbs. No, illumination is more. Like that also you can tell. Then go ahead. 18,000. The circuit of EMF of two batteries are equal. Okay. Suppose both have EMF voltage circuit. The potential difference V and CV between the terminal C and B. Okay. See now 2 ampere, 3 ampere is coming. So here 5 ampere will be coming. 7. Junction rule if you apply. Here 5 ampere is coming. Here 7 is going. So it means from here 2 is coming. So if this is 2, so at this junction, if you see 2 is going like this, 6 is going like this, it means 8 should be coming like this, 8 ampere. Then 6 is coming like this. At this junction, if you see 6 is coming like this, 2 is going like this. It means how much is going here? 6 is coming, and that 2 is going here. It means 4 should go here. 4 plus 2, 6. Yeah. Now this, by using junction rule or Kirchhoff current law, we got these currents. Now they are saying VA minus VB, we will apply Kirchhoff voltage. So VA, I will start from here, VA, then plus 2 minus V. Current is going like this, so this is plus, this is minus. Minus to plus is plus. All are 2, no? V equal to IR will apply. So R is same for all the three. I will go from here to here. So R is 2 into, okay, I will solve it. 4 ampere current, 2 volt, 2 ohms. 4 V equal to IR, 8. Plus 2 minus plus 8. Then you will go from this. The current is going like this only, so plus 2 minus. Here also plus 2 minus. Minus 2 plus 2 into 6, we equal IR. 6 into 2 is 12. Then 8 into 2 is 16. This resistor. Then plus minus 2 plus V. This should be equal to VB. Right? Plus V minus V cancel. VA minus VB, they have asked VA minus VB is equal to, so VA, these are all this side, so that side they will become negative. 8 plus 12, 20, 36 minus 36 volt. But will be minus 36 volt. So obvious because current is going like this, so this voltage is more actual. This negative. So we'll go ahead. Equivalent resistance between points A and B in the adjacent circuit is, okay. Equivalent resistance. If you see, so suppose here voltage is VA and here voltage is VB. So R, if you see, one side voltage is VA Another side voltage is, this is one wire only of resistance 0. So this voltage and this voltage will be same. So this is VB. So here VA and VB. For this, one side is VB, one side is, see, this one and this one are same. So one side is VA. This point and this point are same. This one and this one are same. So these are just wires. So voltage will be same here and here. So again here VA VB. Here also VA VB. For this also, from here VA, from here VB. So all three have same potential difference. So all three are in parallel. And here also, if one point is VA, one point is VB. For this also, one point is VB, one point is VA. For this, one point is VA, one point is VB. So these three are also in parallel, and these three are also in parallel. So all the resistors are in parallel actually. So R, each R, 6 resistors in parallel means R by 6. Right. Then a battery has an EMF of 15 volt internal resistance, 1 ohm. A terminal to terminal potential difference is less than, okay. The terminal to terminal potential difference, right? Terminal potential difference. So if this is resistor internal resistance, so this is plus minus. So if current goes like this, inside the battery, current will go. They are asked in the battery, means current in the battery. The current in the battery goes from negative terminal to positive terminal. This is normal case. And when this happens, current in internal resistance will go like this. So this will be plus, this will be minus. You see plus minus minus plus. So both are opposite. So terminal potential difference will be epsilon minus IR. It is less than epsilon terminal potential difference. So when current goes from negative to positive terminal inside the battery, it is less. Okay, here and here we have. Then if you see from positive to negative terminal, so current is going now there like this. If current goes like this inside, means it is like this. It means it is, this is minus, this is plus. Sorry, current is going like this, so this will be plus, this will be minus. So plus minus plus minus, both are having same polarity, so it will be addition. So that time it will be more, voltage will be more than 15, greater than. So this is there. And when it is zero current, I is 0, so IR will be 0, so it will be equal, right? So it is option A. And we will go ahead. Section B, into sixth problem. Two batteries of different EMF and different internal resistance connected. Okay, the voltage are the same. So now this is like one circuit, right? In this, these are in series. So 3 ohm resistance and voltage also this is plus minus. These are connected like this, right? Plus minus. Then plus of this and plus of this are like this. So both are connected in opposite sense. The net voltage will be 6 minus 3, that is 3 only. And current will be coming like this because this is dominating, right? So from its positive terminal it will come like this, the current will be. So if you see, current will be like this. So this is plus, this is minus. So voltage across AB will be this voltage. This is 6 V is equal to epsilon minus IR here in above case. So 6 is equal to, sorry, not 6. V is equal to 6 minus I is, okay, I also we have to find. This is 3. This is also 3. V is equal to IR. Net voltage is 3. Net resistance is also 3. So 3 is equal to I into 3. I is 1 ampere. So 1 into 1. So 5 voltage is the answer. Here also if you apply, you get correct same only. So plus to minus, because current is going like this. Plus minus plus minus. So voltage will add up. 3 plus 2 into 1. So 3 plus 2 is 5. Now go ahead. So in this 27th, if you see in the figure, ammeter reads a current of 10 milliampere, while the voltmeter difference of 3 volt, sorry, 3 volt. The ammeters are identical. Okay, they will have same resistance. The internal resistance of the battery is negligible. Okay, consider all ammeters and voltmeters are non-ideal. It means they have resistance, right? So what they are telling here, potential difference is 3, and here current is 10 milliampere. They're asking, uh, they're asking, okay, here it is. Resistance of ammeter is, so ammeter's resistance, both the ammeters have the same resistance. Ammeter resistance is m into 10 ohm. What is the value of m? They are asking. What will be the value of m? So if you see, uh, simple only. See, this voltage is 4. It means this voltage is 4, right? From here to here, voltage is 4. From here to here, it is 3. So from here to here, it will be 1 volt. So V equal I R, you can apply now. This is V, this is I. We want this R. So 1 equal to I is 10 milli resistance power minus 2 into R. So R is 10 power 2 ohm. That is 100 ohm. 10 power 2, 1 into 10 power 2. So M is 1. Okay. Now 28, a 5 meter potentiometer wire having 3 ohm resistance per meter is connected to a storage cell of steady EMF 2 volt and internal resistance 1 ohm. The primary cell is balanced against 3.5 meter of it. So this is your potentiometer. This is your potentiometer like this, correct? You go on. So this will be your storage cell, and your primary cell will be somewhere here, which will be balanced, right? So it is balanced against 3.5 of it. When resistance of is 32 by 9, 32 by n ohm is put in series with the storage cell. Okay, from here 32 by n again. Later, this is later part. The storage cell, the null point shifts to center of last wire. Okay, so total length is 5 meters. So uh, this 1 meters wire will be there like this. So it will be 4.5. They're asking what is the n. So how to do this? So initially, see this voltage is how much? Okay, a primary cell was attached. Suppose its EMF is epsilon, and epsilon will be equal to voltage per unit length into length, balancing length. Balancing length is 3.5, and voltage per unit length is voltage across this is how much that we have to find. For that, we have to consider this circuit. In this circuit, initially, if you see this 2 volt, this is there, and this is 1 ohm internal resistance. So initially, the 32 by n was not there. So current and the voltage across this was how much? So first we will find current 2 volt V equal I R 2 plus 2 is equal to I into resistance. Both the resistance are in series. 1 plus this is 3 ohm per meter. So 5 meter is there. 15. 3 into 5, 15. 15 ohm resistance is there of potentiometer wire. So I will be equal to 2 by 16, that is 1 by 8. 1 by 8 ampere is going. So 1 by 8 ampere is going. So how much voltage will be there in total? V equal to IR, that is 1 by 8 into R. R is 15. Right. So this is voltage across whole wire per unit length. Voltage per unit length we want. So V by L. So by L. L is 5 into 3.5. So this much we go. And second case also EMF is equal to 5. This is 5 1. 5 L2 phi L. So L is again, L is 4.5 this time. Is this right? But phi 2 will be again V equal to IR if you apply. This time this resistance is also there. So plus 32 by N you will get. Correct? So I will get as 2 and here 16 plus 32 by N is there. So I will be 2 by 16 plus 32 plus N. 2 by 16 plus 32 by N. This is I. I into R. R of the wire. Wire is R is 15 per unit length. So by 5 into 4.5. Now this epsilon and this epsilon are same. So equate both of them. This and this. Right? If you equate, what will you get? So this side, if you equate both of them, 15 by 5, 15 by 5 will go up. Then is 2 ones are 2 8s are 2 16s are. And you equate both of them, what will you get? This 8 will cancel with this 1 and get, when you equate, what will you get? 3.5. This side is 3.5. And this side, if you see, 4.5 is there into 1 is there, and this went off 1 by 8 plus, oh, 8 also went off, no? 1 plus 2 by N. This much will get. This 5 7s are 5 9s are. So this you take this side, 1 plus 2 by N is equal to 9 by 7. So solve minus this for 1 it is. So minus 1, 9 by 7 2, 2 by 7 will get, 2 to cancel, N equal to 7 will get. Right. Then 29th problem. Find the current in the rightmost resistor shown in the figure. Okay. See, it's 2 volt, 2 volt. Here and here voltage will be same. So this voltage and this voltage will be same. Then this voltage and this voltage will be same. And because potential difference is 2 volt. So this potential and this potential is same. V equal to IR if you apply. R is not 0, V is 0, so I is 0. So current in this is 0. Then you remove this line. There is no current in this. And potential here and here is same. Then potential here and here also should be same. And you remove this source, no current to go. Then potential here and here is same. So potential here and here also should be same. Again, current here is 0. So answer is 0. Right now, they are asked this one 0. Then 30th question. Maybe our last question, I think. So the question: 3 identical resistors are connected in series. When okay, 3 identical connected in series. When a certain potential difference is applied across the combination. R. Total dissipated power is 27 watt. The power dissipated is 24 watt. How many times the power would be dissipated if the 3 resistors were connected in parallel across the same point? Okay. Now same potential difference is there, but they are connected in parallel. Right? Same V is there. They are asking how many times it is of P1. Now if you see in P1 if you see it is V square by R. R is R equivalent, that is 3R. And in P2 if you see V square by R equivalent is R by 3. And this is 3R. So how many times it will be? This 3 will go here. So P1 and P2 if you compare, V1 V square by 3R. So I will multiply 9. This is P1. So it is 9 times of P1. Answer is 9. We can substitute here and find K also. So if you have any other doubts, you can ask. If you have any doubts, you can mention the class. We will end it here.